Welcome to another fun-filled day of chemistry. Please do the warm-up questions and I will be back to go over the answers with you. Question number 1 asks for the percent error equation. And so we have on the top of the lab, it gives you experimental minus theoretical divided by the theoretical value. And the numerator is absolute value, which means that the number will always be positive. So really it doesn't matter if I subtract theoretical from experimental or experimental from theoretical because it's the absolute value. So then I divide it by the theoretical value. Now you will need 3 theoretical values for this lab. The first one is for water. And the theoretical density for water is 0.998 grams per milliliter. The theoretical density for the rubber stopper is 1.34 grams per milliliter. And the theoretical value of density for the unknown liquid is 1.26 grams per milliliter. So you will need those values in order to put them into this equation or this formula. Now the experimental, that's what you will find in the lab. So by measuring the masses and the volumes, you will be able to determine the experimental values. Actually, we're going to be doing it together, so I'll help you in doing that. Now in the lab, we will have a graduated cylinder. And we always read the bottom of the bubble. And that bubble is called a meniscus. And we'll read the graduated cylinder to the 10th place. So that's the information for number 1. Number 2 is a density problem, very similar to what we will be doing in lab. Density is equal to the mass divided by the volume, and we are solving directly for density in this problem. So we are given 5.1 grams as our mass, and the volume is 4.5 milliliters. Now when I do the math, I will get 1.1333. Now when we are calculating, we always go 4 places past the decimal and cut it off. So this would be my answer so far in my calculation. Then for the final answer, we will look back at the original problem, and the number with the least number of significant digits as given in the problem will be how we express our answer. And so that will be 1.1 grams per milliliter, because grams and milliliter are totally different. They don't cancel each other. So I have to keep them. I can't change them. So that would be my final answer for the density. Now in the lab, that's exactly what you will do. We will find the masses of the various substances and get the volume readings and be able to determine our experimental densities. So now it's important that you tie back your hair, make sure you have shoes on, and goggles. So I'll see you in the lab. Now I get to do lab. I get so excited doing lab. I just love it. Now the first thing we need to do is have my beaker, and I am going to weigh the beaker. And it's already on 0. I am going to place the beaker on the scale and get a measurement. It is 29.96 grams. Notice that my scale is measuring to the hundredths place. So I need to put that on my data table, 29.96. And I am going to zero that out. because I want to put 50 grams of water in here. I will pour my water in, and it goes very quickly. Oh my, I'm filling it up. Oh, good. It didn't quite go over. However, it did go over 50 grams. So I'm going to take a small amount out, and I have a waste beaker here. Oh my. You can see that it takes some effort to get exactly 50, and I actually am not going to try to get exactly 50. I'll take the 50.59. That works for me. The 50.59 is the mass of my water. 50.59. Now, if I want the beaker and the water, I would have to add those two numbers together, the mass of the beaker plus the mass of the water. And I could add those two together to get, in my data table, the beaker plus the water. However, it was easier for me to do it this way so that I could just get that 50 grams of water. Now I am going to place it in a graduated cylinder. I will pour it into my graduated cylinder and try not to spill any, because if I spill some, that could be a source of error and it would affect the density that I'm going to determine. And I want to look at the bottom of the meniscus, the bottom of the bubble that is on here, and the measurement. And it is exactly 52. It is exactly 52.0 milliliters. 52.0 milliliters. And those are the values I need to determine the density of water. And you were given the theoretical values for water. Next we have the unknown liquid. I am going to put the graduated cylinder, the small graduated cylinder, on the scale, and I'm going to zero it again. I'm going to weigh out what this is, and the small graduated cylinder is 27.31 grams. 27.31 grams. Now I am going to add my unknown liquid, and I want to get 5 milliliters. I'm going to look at it straight on and pour in 5 milliliters. And I'm going to stop. It's very thick liquid. And I'll show you as soon as I get it done. And, oh, I got a bit much. I'll take some out. And I never put materials back into the container. We just don't do that. So I will have to place it into my waste beaker, and I have a waste beaker here prepared. I need to remove a little bit more. And now the line on my graduated cylinder is on the bottom of the meniscus, is on the 5. So I have exactly 5 milliliters of my unknown liquid. And I will put it on the scale again because I need the mass. It is 33.18 grams is the mass of the graduated cylinder plus the 5 milliliters of my unknown liquid. I can determine the mass of that 5 milliliters, and I know that it has its volume is 5.0 milliliters. And I can determine its density experimentally. Finally, what we have is a rubber stopper, and we are going to determine the density of this rubber stopper. I'm going to add it to my scale, and I get 6.19 grams. 6.19 grams is the mass of this rubber stopper. Now I am going to place this into my graduated cylinder, and I want exactly, it makes it easier if I have exactly 50 milliliters in here. So I have exactly 50 milliliters of water in my graduated cylinder. Now I am going to add this rubber stopper in gently, gently, gently into the graduated cylinder so I don't splash so much. And I'm going to read the new volume. And the new volume is 54.5. 54.5 milliliters is the volume that this rubber stopper is displacing the water. So the volume of this rubber stopper minus the original volume that I had of the water, it will determine the volume of the rubber stopper. I have the mass of the rubber stopper, and therefore I can determine the density of that rubber stopper. Now you've been given the 3 theoretical values, so we can determine what our percent error is, and you have to go ahead and write up this lab with all of its parts: title, objective, procedure, data table that we just gathered all the data together, and answer any questions that are asked. And I believe that you are going to have to do percent error on this lab so we can find how close my actual experimental data is to the theoretical data. And we want to take those densities to the hundredths place. We're going to round them to the hundredths place. And there you have it. That was so much fun. I was so glad you spent this time with me, and I can't wait to see you tomorrow.